Alright, so today we're going to be talking about theoretical yield and how to get your theoretical yield. And to do that, first you have to have your reaction. So here we have A plus B yields C. And then we have our table of our grams per mole and the gram amount that we have. And X is, of course, our theoretical yield that we're trying to find. So first, what we have to do is determine which one of the reactants is the limiting reactant. So to do that, we have to convert our gram amount into moles. So we do that by just simply starting out with the 2, since that's what we said we have from the table. And then we multiply that by the gram per mole amount, our molar mass, which is 14 for A. So we would then do divided by 14, and then 1 mole on the top. So 14 grams down here. So this leaves us with, since this is 2 grams, grams cancels out, and we're left with 2 divided by 14, which is 2 divided by 14 gets us 0.143 moles. So that's how many moles of A we have. That's how many moles of the reactant we have. But now we have to convert this molar amount to our molar amount of C with a mole to mole ratio. And since it's just 1, the mole of A is going to be equal to C. And you can do the math for that if you wanted to. It's just 1 mole of C over 1 mole of A, and that just gets us the same number, 0.143. So then what we have to do with this number is convert it to our molar mass of the product. So we take our molar amount, 43 moles of C, and all we have to do now is multiply it by the 30 grams, because that's what our table says for C, our gram per mole, and it's just 1 mole on the bottom, 1 mole C. So then our moles would cancel out. We just get 30 times 143. So that would get us 4.29 grams. So from A, we would get 4.29 grams of product from this reaction. So that's our A. So now we have to do the same process with B. So let's erase all this. Taking a while. And then we just do it all again. So we have 2.5 this time grams. And then it's now 16 grams per mole. Which would get us 0.153 6. It's a bad 6. There we go. That's what it would get us. And now what we need to do is convert it to moles, but it's still 1 to 1. So, I mean, you don't really have to do it since 1 divided by 1, or 1 times 1 is just 1. So, the mole is still the same. And now we just gotta multiply this molar amount by 30 grams from the table. So multiply by 30 grams over 1 mole. The moles cancel each other out, and we're left with grams. We do this by 30, and it's 4.69. And this is a greater number than the A, so that means A is our limiting reactant since it was producing less amount for C. So that would make A our limiting reactant. So that means that's what we have to use as our correct. That's what we have to use that's our theoretical yield. That's what that number is. I forget what it was. What was like 4.2 something 5 or something. Okay. So the 4.29 would be our theoretical yield for C, since that's what our limiting reactant gave us. So we can get rid of this X, and it's 4.29. And that's our theoretical yield. And then if we wanted to, we could go into, if we were giving our actual yield, so say that in an actual experiment, we got 2.97 grams. All we have to do to get our percent yield is just divide that number by the 2.9 grams to get us our percent yield, which 2.91 divided by 4.29 equals 68%. So we would get 68% of our theoretical yield if we got this amount, if you ran the actual experiment. But what you have to keep in mind in these theoretical yield problems and equations is that it might not always be a 1-to-1 ratio. So, for example, if we do 2 moles of B for the reaction to work, we would have to, let's write it all out again, 2.5 times our 16 grams from the table, and the 1 mole get us 1.56, or 0.56, my bad, 0.56. And then, since it's not 1-to-1 anymore, we would do, and this is 0.156 mole of B, we would divide by 2 moles of B, since that's how many is in the reaction, and 1 mole of B, or 1 mole of C on the top. So that would mean we would have to divide by 2, which would get us 0.078. And 0.078, then we go down here, 0.078 mole of C times the 30 grams from the table. Would get us 2.3. So now, in this equation, the B reactant would be our limiting reactant, and then our theoretical yield would be now 2.34. So that's something you got to keep in mind when dealing with these reactions. And that's about it. Percent yield, limiting reactant, mole to mole conversion. Yeah, I think that's it.